everyone, and welcome to APS Webinars. The title of today's webinar is Transitioning from Physics to Data Science, Gain the Required Skills in the COVID Era. I'm Midhat Farouk, and I'll be your host for today's broadcast. Thank you all so much for joining us. APS Webinars are brought to you as a service of the American Physical Society, connecting you with the expertise of individuals who can offer insight into physics careers, educational programs, and professional development for students, working physicists, and educators. Today's presentation features Mohammad Soltanieh-ha, physics Ph.D., data scientist, and a faculty of information systems at Boston University. Mohammad will be talking about some helpful resources for those looking to transition into data science jobs in the time of COVID, as well as his personal experience in the field. After he finishes the presentation, the remainder of the program will belong to you for our question and answer session. Because of the number of people attending the webinar, we are only accepting text questions. So, if you would like to ask a question, please type it into the questions panel located on the right side of your screen. You may submit questions through the question panel at any time during the webinar, and we will answer the questions after the talk. We will do our best to cover all of your questions that you submit, but we want to apologize if we are unable to cover everything. Finally, a link to the recording of today's presentation will be emailed to you after today's event and will be made available on the webinar homepage. Please allow up to 5 business days for video upload. We encourage you to complete the survey upon exiting so that APS Webinars can improve its ability to provide you with these valuable services. And so with that, let's get started. Dr. Mohammad Soltanieh-ha is a clinical assistant professor at the Information Systems Department at Boston University's Questrom School of Business. Mohammad obtained his Ph.D. in computational physics in 2015 from Northeastern University, where he studied strongly correlated electronic systems in low dimensions. His current research interest revolves around computer vision applications in automating cancer diagnosis, as well as large-scale, high-performance computing. His teaching experience includes data science programming, big data analytics, and applications of data science in business. Mohammad has leadership roles at Google and the American Physical Society. In 2019, he founded a data science unit within APS and is currently the past chair. Additionally, he is a faculty expert at Google Cloud, where he advocates for cloud computing education and helps other faculty members with best practices. Okay, Mohammad, take it away.
Thank you very much, Midhat, for a very generous introduction. Hi, everyone. And I also would like to thank APS for giving me this opportunity and inviting me to this webinar series. I'm going to just skip this one since Midhat already mentioned that I'm a faculty at Boston University and also a faculty expert at Google Cloud. So today I will be sharing with you my experience, and I will be also sharing some tools and some resources. I just want to put this disclaimer out that all of the opinions expressed in this talk are mine and not one of the institutions that I'm affiliated with. These slides would be shared with you at the end of today's talk. My last slide, I have a link. There are some hyperlinks here. You would be able to download the slides and click on those hyperlinks if you wish to. Before I get started and talk about the agenda, I just want to say that at the time Midhat invited me for this talk, at first I thought this would be one of the most embarrassing talks because you have to talk about yourself and talk about your past. But it immediately reminded me of a webinar that APS hosted. It was hosted by Crystal Bailey, who is a great resource at APS for careers and guiding students, like myself at the time, for finding their career and choosing the right path for themselves. And that webinar was extremely helpful for me, just to hear the words out of another physicist's mouth and the path that she took to get a data science position. It was extremely helpful. So I thought, for the very least, I could share my background and my experience and some of the resources that you might know most of them, but maybe there is something here and there that I hope you would find in this talk helpful. I will start with the background, the embarrassing part. and then I'll get into my personal experience for this transition that I moved from physics to data science, try to solve different types of problems. I usually like to say the same math, but different kind of domain problems. And then talk about job search in general a little bit, and then job search during COVID, the kind of challenges that some of you might be facing at this time, maybe making this transition even more difficult compared to when I did it. However, the amount of resources out there are significantly more, so hopefully that can make up for the extra challenges that you're facing today. And briefly talk about building a strong resume. By no means I'm not a resume expert. However, I have been on both sides of the aisle, on the hiring side, as well as writing my own resume, and I'm happy to share my limited experiences. And then talk about data science skills, what are the skills employers are looking for when they're hiring, and some resources at the end. All right, so the background, I started my higher education in physics, and basically my undergraduate and master's degree, both done in Iran, the University of Tabriz and Shaykh University of Technology, both in physics. I started getting into programming. In fact, my master's thesis was all simulations, the results of my experiments, the statistical physics. And that was when I seriously got into programming. Before that, it was more for fun. I didn't have an application for programming, but you know, my master's degree opened my eyes to C++, and I did lots of coding there. I started my Ph.D. at the University of Wyoming in 2010. However, I transitioned 2012, transitioned to Northeastern University. So I got another master's degree also in physics from University of Wyoming. So that was up for grab, and I went for it. Right before I graduated, so you can see the timeline here, which I thought might be helpful to picture the important dates in my career so far. 2015 was a busy year. So right before I graduated from my PhD at Northeastern University, I was contacted by ApS to help help setting up this new unit at the Boston area, which was called Boston Local Links, which its goal was to connect academia with industry folks. And I thought that's a great opportunity. I was in the job search myself, and I thought I would meet a lot of physicists in industry, and that would expand my network. That was my main motivation, if I want to be honest, that I'm going to start doing this, because I had no prior experience with ApS and organizing or basically managing one of these units. But it turned out to be a great experience. I'm still involved with Boston Local Links. However, I landed my job right before first event was scheduled. But I thought, you know, this is fun. Why not? Let's continue doing it. So you know, the next day after I defended or officially graduated from a PhD, I started my job at Infor Dynamic Science Labs as a data scientist. And so I was there for about 3.5 years until I came across this position that BU reached out to me to basically teach what I'm practicing in, you know, what I'm doing every day as a data scientist at BU. And I thought that's an excellent opportunity, and I love teaching. So I jumped on it, and I was looking for research, some research components to my days, and that was something that basically this new position at BU has fulfilled. And I'll briefly talk about my research and the works that I've been doing in these places. Last year, again, ApS reached out that if we could set up a topical group on data science. And I thought, absolutely, why not? We need such a unit to support students, support postdocs and faculty, and also industry folks, industry physicists that are not really in touch with ApS anymore. So I helped founding that. unit. I'll talk about it at the end of my talk very briefly. I was the chair last year. Currently, I'm the past chair for that. So there are a lot of resources here I would like to point out at the end. And then this year, I've been very much involved with Google Cloud, and I've been using them in my research and my teaching. And starting this year, I became a faculty expert. My job there is basically to advocate for cloud computing and help other faculty to utilize Google Cloud in their classrooms and research. All right, so most of the embarrassing part is over, but this talk is going to be about my experience. So it's inevitable. I'll try to just give you the pieces of information that you might find relevant to this. So my PhD thesis was interplay between charged spin and phonons in low-dimensional, strongly interacting systems. So you might think, what does it have to do with data science? In fact, it turned out it had a lot to do with data science, right? It is basically also a lot of simulation, a lot of coding, and we use machine learning. And at the time, if I want to be honest, I didn't know it was called machine learning. We were using dimensionality reduction and such. So it was, I had a lot of skills already that I didn't know I did. But when I did the transition, I realized this was not that unnatural of transition. I just, the path wasn't very clear for me. It wasn't paved. The department, physics department, any of the physics departments I've been at, and there are 4, none of them could actually give me any helpful advice on finding a job other than postdoc after a PhD. So the path wasn't very conventional, at least at the time. But once I took it, I thought, this should be laid out more, and we should talk about it more for people who are doing it. So I'll during my talk, I'll talk a little bit more the things I did. But what I did at my first job as a data scientist at Infor, I worked on an array of problems, maybe 5 or 6 different problems. I put here 4, and these problems inherently, the domain was very different from physics. But as I mentioned earlier, I call it math is very similar, optimization problems and machine learning problems. So the first problem I actually worked on was this price recommendation for distributors. I was put in charge of working with this client, multi-billion-dollar client, that they wanted to recommend prices to their customers, have fair prices, and I had 3 months to work on it. And that was quite an interesting project, coming with no pricing background. I had to read up some books, and at the end of the day, I realized this is the model that I designed, and it was approved. It's far simpler than the kind of models that you would design in space like physics. So I thought there is a lot of opportunity in this space. The other problems I worked on, hospital inventory optimization, worked with a lot of healthcare data, time series anomaly detection, and customer churn forecasting, which is one of the most popular problems for any business that they want to keep maintain their customers. Currently, what I'm working on is computer vision and image classification in cancer research. So this is work based on deep neural networks, deep learning, and we are trying to automate some of the work of the pathologists, not replacing the pathologists, but help them to diagnose cancer with higher accuracy. The other research area I'm actively involved with International Monetary Fund is time series forecasting, and we are trying to build a model, if we can, more accurate than what International Monetary Fund is currently using for forecasting GDP and fiscal deficits of the US and of the other countries that we have data available. So the general theme in all of these projects is programming. For vast majority of the machine learning, data science, depending how you look at it. Okay, so let's go back in time. This is 2014. I had to make a decision whether I want to stay in academia or go to industry, and what path I'm taking. If I want to go to industry, what is the job title I'm looking for? What position I'm aiming for? It was arguably one of the hardest decisions I've made, but and at the beginning was very foggy. It was not this clear at the beginning. I had no clear idea. I tried quite a few different paths because I was exploring, and I realized, nope, I'm not interested. I didn't have all of that knowledge. One of them was actuarial, that I was like, oh, this requires a lot of math, and I love math, and let's see. But I didn't find myself interested in doing it. But I ended up data science. There were a few things that made it easier for me, and I can't emphasize enough that how each person's path is different. So if you hear other folks that have switched domains, they're going to tell you different story. Even people going from physics to data science. Excuse me. So one of the things that I consider myself lucky coming across was this Wolfram Research Summer School in 2014. I got lucky to find out about this workshop. This is basically a 3-week workshop that summer school, and I learned a lot of during the 3 weeks. First of all, I read. I shouldn't say read. I skimmed over 1,000 pages of Stephen Wolfram's book. During that time, I learned how to program Mathematica, and I worked on a project that actually finished it within that time period. I don't know how I did it. I remember I didn't sleep during those 3 weeks. But the project was, this is basically my first data science project outside of physics, short time precipitation forecast. So this was, Stephen Wolfram defined this project for me, and his idea was, can you predict if next hour you're gonna get rain or not? And his idea was to get radar images. It's funny because it's raining very hard right now here in Boston. This image is from 6 years ago. But I had no idea how to work with image data, and I had no idea how to get the data, radar images, and no idea how to track these raining clouds. But it turned out you can figure out. You just the hardest part was getting the data, access to the data. After that, there's a lot of resources out there, and you just have to be looking for. So this was amazing because it was the first time I had a project that with simple words I could explain to someone who is not a physicist about what I know and what I do. Before that, I would go talk to people in career fairs in different areas, and I would say what I do, and I would get a very cold response from them that, cool, and nobody wanted someone in industry, at least in most industries, that does quantum mechanics simulations. And this is not really what they need. They need something more practical, and also they need to understand what they're doing. And in order for someone to understand what you're doing in low-dimensional physics, they have to know low-dimensional physics, which is very small, very, very, very small subset of us, right? So this was really helpful. It gave me a story to tell when I talk to people. The second event that I consider myself very lucky to come across was also in 2014. I joined as a teacher to this nonprofit organization, RoboSail, that we taught programming to high school kids. We did that in a very fun way, which was not my idea. The main instructor had the idea, but we helped hack these sailboats. We added a bunch of sensors, wind sensor, compass, accelerometer, etc., add a Arduino board and program it. And this is actually the final day of the first semester class that we had. This is the competition. The competition that the student teams, they were supposed to do a course, come back, whoever comes back becomes the winner. And basically, this was my first robotic experience. Just as a side note, I got an interview from Amazon Robotic Group just because I had done this. They reached out to me in a career fair. Just somebody walked to me and said, "Are you interested about applying any jobs?" And I was like, "What do you do?" Because they weren't advertised as Amazon, but they were Kiva, which is one of their companies, and I said we do robotics, and I was like, oh, I teach robotics. Of course, this was very basic robotics, but it was very attractive to them. So this kind of experience helps a lot. If I said I do quantum physics, they wouldn't be even talking to me. They would go to the next person. So my transition in very few brief words, meetups in Boston. I was lucky that there was no pandemic, and every week, once or twice, I would go to meetups, have a free pizza and a free beer, and chat with people, and basically go to the talk, learn what they're doing, and meet new people. I didn't find my job through a meetup, but I learned what I was interested in. I went to a lot of career fairs. I did find my job in the career fair, ironically at BU. I went to a lot of resume review sessions. I spent a lot of time on my resume because I had no idea how to write a good resume. And then quite a few interviews. I probably applied for 10 jobs. I got 3 or 4 interviews and 1 offer. That's all you need at the end of the day. And I found a story to tell. That was, I hope that from the past few slides, this would be a point to be taken here is find your own story. Your story is going to be unique to you. Find your own passion and something that you can talk about to other people. All right, so fun stuff. Let's talk about it. Job hunting, applications, resumes, and interviews are all fun, right? Said no one ever. But this is important. So what is a good strategy for job search? And I say good, some of these things are things that took me months to figure out. Narrow down what positions you're qualified for and interested in. Literally months, maybe even close to a year to figure out what I want to do. I started earlier. I started about a year and a half before finishing my Ph.D. to explore and see what it is I want to do. And it's really important. Networking is key. You have to meet people. You have to talk to people. You have to tell them your story. You have to practice your pitch. And resume, I probably spend hundreds of hours on my resume. It's not exaggerated if I showed it to 50 people. Ask for people's opinion, and it's priceless. Go to speed dating resume reviewing sessions. Go to your career center if you're still a student and you have a career center. They're doing a lot of virtual meetings these days. Go to career fairs and show your resume to people and ask them about their opinion. What do you like to be added in this resume in 6 months or a year in order to interview me? It's really helped me. So resume speaks for itself, but perfect your pitch, your elevator pitch, when you're present, right? When you're there. This has happened to me. I've been in career fairs that I'm on the other side of the table hiring, and I ask someone what they do, and they're reaching out for their resume. And that's not very attractive, right? You want to have a 30-second pitch ready to give that to the employer. Find out what skills are needed and learn them. This is one of the things I would ask in career fairs. What are the skills that your data scientists are doing? For whatever position at the time I was looking for. What kind of programs, what kind of tools they're using? What should they learn? Strong skills can get you the phone interview. However, the applications are what they're gonna get you the offer. So you want to find an application for the skills. Just don't go and learn Python and learn all about data types and everything that you can do in Python and not having any sort of experience. People will ask you, okay, you say you know Python. Usually everyone knows Python these days. What have you done with your skill, with your programming skill? Okay, so what else? Put yourself out there. Before I start this, I just want to mention something. This area, one advantage that you have right now here is that it's one of the areas that has been impacted the least by COVID, by the current pandemic. A lot of people found a job, in data science before pandemic, but it was all virtual. They met someone, on LinkedIn and send a resume, interviews. They maybe even didn't go for an on-site interview. It was a video interview. They got the job and they started working remotely. Most big companies, they have a lot of remote position. So a lot of these things here that I'm sharing with you would apply during pandemic or outside the pandemic. Build a strong online presence, even if the pandemic ends today. Have a very strong online presence. Stay active on LinkedIn. Polish your social media presence. Really important. But build a good portfolio, a portfolio that describes what you can do for the employer. They can see the proof of the things that you're claiming you know. Meet new people in the field. You know, if it's harder to meet new people in today's situation. I'll talk a little bit about it, but there are ways to do it. And once you meet them, ask for their advice. As I said, show your resume, say, hey, how can I make it more marketable? What was your personal path like? People love to talk about their personal experiences. Ask for introduction. You know, be careful that you're not using up all of your tokens, but if there is a person that you know, LinkedIn is very helpful. Maybe even the paid version will give you a lot more insight into, hey, you know a person that knows a person in this company that you're interested in. See if you can actually ask them to introduce you to their colleague. Apply online, it's fine. However, most of online applications are not going to get to the hand of the hiring manager. Try to focus on places that know you. And that's why my application numbers are so low. I would apply. The job I got, the hiring manager called me and asked me to apply. I had met them in a career fair. I was like, sure, I'll do it. Before that, I personally didn't apply a lot online until there was a connection. There was some sort of, I was sure that they know me. So what can you do during the COVID time? So you want to consider internships if you are not being able to get a job right now because a lot of companies are not hiring. However, a lot of them are, especially in the digital world and the data science space. But if the job search itself is not very successful, consider paid, unpaid internship or volunteer experiences that are related to the area that you're looking for. If there is none, start your own project. Start for your business idea. Increase your digital footprint. I talked about portfolio. I can't emphasize enough. Do projects, put them on GitHub. Put a link of your GitHub on your resume, or write up articles. If there is something that you know, you would be surprised. People write articles that become really important to the community, and there's something simple, just because they save somebody an hour of figuring things out. They show how to do this and how to do that. Go write up an article on Medium. It's anyone can write and publish an article on Medium. It's not peer reviewed. Find a short-term project. Reach out. Maybe have a colleague and ask them, hey, is there anything you're struggling with these days? Maybe I could help. I'm not looking for an employment, but experience. Everyone can use some help if you have some proof that you can actually help. Online courses are amazing. This is an area that probably has grown by a factor of 100 by the time I was looking. Coursera courses, edX, Udemy, DataCamp. These are all the platforms, some free, some paid, that you can actually take courses and brush up your skills, learn new skills. I use them all the time. Whenever I'm designing a course for BU, I probably go over 10, 20 of these courses. I go on 2x speed, just see what people are using, how they express it. They're great for learning new tools, new techniques. If it's hard to meet new people, the current situation, try to host the event yourself. It's never been easier to host an event. You don't need to worry about the space. It's visually free. You just have to have a good idea to bring people to your event. Have a 1 hour and a half event. Invite your friends and ask everyone to bring a colleague. And then say, hey, I'm looking for this kind of positions. Do you guys have any experience? Do you know anyone who's gotten a position similar to this? Can you connect me with them? Join data science hackathons or competitions. Kaggle, if you haven't heard of Kaggle before, it's a great resource. They launch a lot of data science competitions basically on a daily basis. Some of them are for prize, some of them are just for practice. Just go make an account, it's free. And you can also see a lot of people's solutions when they share. And attend virtual conferences. A lot of conferences before that you had to pay $1,000, $2,000 fee, they're making either a lot cheaper or free because the cost of conferences has gone down. They're taking the venue out and a lot of receptions and things like that. So you can basically attend a lot of conferences for with no financial struggle, and go to their forum. They have career fairs. Submit your resume and just be active all the time. Again, I'm not a resume expert, but just a few pieces of advice, and I want to point you to the APS's careers page. And specifically, I have benefited a lot from what Phil Bailey has worked on in the past several years. There are a lot of great resources there. But just a few quick things. Resume is not a CV. That was something that it took me a while to figure out because no one in my department was able to actually help and navigate me through that. But this was something that the Career Center really helped me with. It takes a village to build a good resume. Again, get professional help, go to people who know what they're talking about, get feedback from many people, as many as you can. Tailor your resume with the job description. Cannot emphasize how important it is. If you want to stand out, you want to write a complete separate resume for the job that you're applying for. And it's going to be different for each job. You want to highlight different experiences that you have related to that job. You want to use the same phrases if it makes sense. Use the same words if it makes sense. If they've used, they want someone who is proficient with scikit-learn in Python, and you want to highlight that. You don't want it to be buried somewhere at the bottom or not mentioning it at all. All right, so let's see a few more things here. Connect the dots, have the skills and also use them in your experience. Limit it to one page, unless under very special circumstances, if you have many years of experience. 2, never go above 2. Don't do 1.5. It should be either 1 or 2. Most people will tell you never go above 1. But I personally think it's okay if you have many years of experience. Keep it professional, but still interesting and relevant. And your resume should be different than your online profile. It should tell the story about that job, not about you, just like the timeline I just showed. If I'm applying for a job right now, I'm not gonna just show that same timeline to every employer. I'm gonna tailor it to the job. All right, so and then work on projects, add them to your GitHub. I can't emphasize enough. So what does make a data scientist? So I'm gonna mention a few things here: math and statistical modeling, programming, visualization, databases, verbal and written communication skills, domain knowledge, problem solving, storytelling with data. So these are the high level characteristics of a data science. Arguably, you can add a few more if you want. A nicer list on this side. How about a physicist? Well, very similar. You already have a lot of these skills ready, available from your physics training. The ones that I haven't made green, like databases, usually you don't learn about databases during your physics training. In one of the interviews, I was asked to solve a problem. It turned out it was a 3-line solution needed. It took me 3.5 pages, 4 pages, maybe in C++ to write that. And I designed a database in C++, and I had no idea what databases were. Of course, I didn't get the job, but I'm sure I made a lot of people very happy that day just to see that solution, and they probably gave them good laugh. But this is very easy. That's one of the things that you probably can learn over a weekend. If you know companies are using it and companies are looking for, go through job descriptions and see what they're looking for. And variable location typically is not the strong suit of a physicist. Work on that. Again, networking sessions would help. Put yourself out there. And the domain knowledge. Most places do not expect you to know that right off the bat, but some do. So if they do, you want to work on that. Storytelling with data, In physics, usually, yeah, do it. Maybe not as strong as a lot of industries that they expect you to do. Or written communication, yes, you do. You write papers, you write different things, but different styles. So these are the areas that you could work on while you're working on your technical skills. Don't have a lot of time left, so I'm going to speed up. I have quite a few slides left. Data science skills that you would need: Python programming. A lot of people ask R or Python. This is the age of Python, I believe, or maybe closer to the end of age of Python. But at least still, right now, we're living in Python era. Most companies are hiring with some of the Python background. R is great tool. That's where I started. After other languages that I learned for data science transition, C++ wasn't interesting. Mathematica wasn't of interest of employers. R was. I started learning R, and then later on I started, programming in Python because of several good reasons that requires a different talk. Jupyter notebooks or Colab notebooks are great. Data wrangling, pandas in Python. Let's see, Linux. Learn the basics of operating Linux. This is SQL, SQL. Statistics, probably already have a portion of the statistics covered. Machine learning, deep learning, these are the name of the packages that I have here. Scikit-learn in Python, TensorFlow, Keras, these two are for deep learning. Amazing things to know, very interesting also employers are looking for. Visualization, that's actually where I started my journey to this transition. I started using R to make data visualization because R has a very interesting package for data visualization, ggplot2, and this simplified my life quite a bit for my PhD research. And then later on, I was like, why can't I just do a lot of things here? Why do I have to do in C++ and requires a lot of time coding? Cloud computing is becoming more and more popular, and employees are asking. And then finally, this is not a must, but these last two are good to have. DevOps, so software development and IT operations. This is an area that if you're learning some Linux, you want to learn some about this as well. This is a skill that data scientists are expected to know. So let's talk briefly about resources. By no means this is an exhaustive list, but it may be a good starting point. At least for me, the one that I started taking when I was a student was this data specialization by John Hopkins, Coursera. It's free. You can also pay to get the certificate, but I don't think most companies care about seeing the certificate. It's a series of courses. It's all in R, so maybe a little bit outdated by now. There are other things in Coursera Go. I actually searched data science in Coursera for specializations, and there were over 100 popped up. So deep learning specialization by Andrew Ning. It's basically by deep learning AI. It's a great course and a resource. Some of the books that I think are must read: Python Data Science Handbook by Jake Vanderwals. He was an astronomer. It's a really good book. It has a lot of sample code you can go through. R for Data Science by Hadley Wickham. If you want to learn R, start with this book. It's amazing. Hadley is the founder of Tidyverse package. And then two more books here. So the deep learning with Python is by one of the founders of Keras, which is the deep learning platform. I thought to share my summer book list so far. I hope I can get through these this summer, given the fact that we can't travel or go anywhere. I probably will. And again, I'm going to share this slide with you if you wanted to click on any of these hyperlinks. And then the last set of books that I'm sharing, they are non-technical. Strong them. All of them are available also in audiobook format. So take advantage of them. I think I listen to all of them and read just your time or whenever. These are data science books, but without actually talking about the techniques, but about the domain itself. And then finally, lastly but not least, I promised to talk briefly about topical group on data science. This is a group that was founded last year. And as I mentioned, I'm currently the past chair. We have been hosting a lot of virtual webinars. This happened in response to cancellation of March meeting 2020. We've had 11 or 12 webinars so far. All of our webinars are recorded and can be accessed on YouTube. All you have to do is look up ApS Data Science on YouTube or ApS-G. So GDS is the acronym for our group. Become a member of this unit. We have you can have influence if you're interested. We will have open positions. If you want to get involved, reach out to gds@aps.org and express your interest that you want to get involved. We have our newsletter from a few months ago, so you can check that out. And also follow us on social media. We are on Twitter, Facebook, LinkedIn. With this, you can find us with ApS Data Science. All right, with that, I would like to stop here. You can get access to these slides by going to this short link. It's case sensitive. So ApS, the bit.ly, ApS, SWS. I think it was Summer Webinar Series 20. Thank you. And if there are any questions.
Yes, thank you so much, Mohammed. We're definitely getting a lot of great questions and a lot of thank yous and people saying that this is great advice. So with that, I'm going to move on to our first question. So you said that you did a lot of exploring initially to find the right job. Can you expand on what you did? Was it reading about a specific topic, working in different internships or workshops, or actual jobs?
That's a great question, and I think it was a combination of all of the above. I didn't know many people in physics who were doing non-physics work, and that was quite a challenge for me. I have learned now that ApS has a lot of resources that you can, if you go to March meeting, there are several forums. There is forum for early career scientists. There's forum for industrial physics. And they have events that you can go and meet with people who are doing non-research jobs. And I didn't know at the time. I went through a lot of meetups, as I mentioned, meetups at Microsoft, meetups at Google, meetups at Amazon, different places, and smaller companies, and talk to people, not necessarily physicists. It was hard to find physicists for me. And a lot of it was reading up online. What is this job? What is the day-to-day job? But one thing I learned later, and I didn't use it a ton, maybe a couple of times, was doing an informational interview with someone. Once you find someone, reach out to them, say, hey, if there is no COVID, say, do you have some time, maybe 15-20 minutes, grab a coffee, and I have some questions about your field. And people love to do that. During right now, virtual events and virtual meetings, and reach out to someone on LinkedIn, say, I would love to learn more about your company and what you're doing, and don't say anything about getting a job. Apply. Even after you met, just get the information and see if this is really what you want to do. If sometimes people would ask themselves, send me a resume, and that's what you want.
Okay, thank you. Next question. Of the data scientist skills list, which do you feel applicants often overlook? Which one really makes you stand out in a good way?
Great question. I think there are some of these skills that anyone who is applying a job has at least heard of or know some, and those are programming or something like Excel, which I didn't even include here, that people would automatically know. One of the skills that is oftentimes overlooked, I would say, is statistics and math, and that's something people don't put a lot of. People do a lot of machine learning without understanding what is happening under the hood. So you want to know the theory. You want to put your scientist hat and say, not only I know all of these things that the data scientists know, but also I know the mechanism behind them. That makes you more attractive, but also applications. So we have to be careful that you're not pitching yourself as a theorist, People say I belong to a research lab, not to a company that wants applications. But also at the same time, I want to know the statistics. That's my strong suit. I would say, learning these skills usually really fast. Usually some of these courses that are out there, within 4 hours, you will learn generally what SQL is. Of course, you're not going to become an expert. It's going to take a long time, but it's really quick to learn. But that's not the case with something like a statistic. As a physicist, you have the foundation. You already probably know all of the things you need to know. You just have to go reread them with understand the language that is being used in the domain. So I think that's where I would put on statistics for this question.
Thank you. Okay, this one's interesting. Thank you for an amazing webinar. Could you recommend programs, skills, or series which would help an undergraduate student apply to PhD programs in scientific, computation, or data science?
Excellent question. Scientific. Can you repeat the last part of the question one more time, please?
Yes. Something that would help, so programs or skills or a series which would help an undergraduate student apply to PhD programs in scientific computation or data science?
I would say the programming part and data visualization, those two skills are probably among the ones that I have listed up here. And also stats are very, 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 very much in common between a scientific program and an industry job. And if you are a good programmer, it doesn't really matter what tool you use, because you just can move easily around if you have that logical thinking and the programming thinking to basically work through. So you want to build a strong programming background for yourself, work on different projects, write a lot of code, learn how to debug, what to look for, and data visualization. These are plus the stats that I mentioned already multiple times. These will make you very attractive. Let's say you're applying for a PhD program in a scientific program. What series can you use? I would say a lot of, so for instance, the deep learning. If you want to do in the future, your research area in a scientific program could be deep learning. A lot of programs, including physics programs, are using deep learning for, let's say, image classification or exploration or for clustering. There are a lot of different areas that physicists are using deep learning, machine learning. And of course, a series that I would strongly recommend is this one by Andrew Ng. And it's not just him, but he's the one who actually has has a few courses here, but he's moderating some of them. Has a lot of good amount of theory, so it's going to help with that research program that you're interested in, as well as if you choose to, after you finish your PhD, get a job in industry, it's going to give you also that practicality of these methods as well. But I would say a lot of these are transferable. If you're learning Python Data Science Handbook, right? They're learning how to work with data. Vast majority of research being done today is working with data. So it's going to be very, very transferable between either an industry position or a research position. That's what I would say.
Thank you. So I'm going to sort of combine two questions that I'm seeing. So what would be better for someone finishing a PhD in physics? Work on data science projects in the spare time, or do a 2-year master's in data science? And related to that, other people have asked about how much time it takes to become an expert in some of these skills that is required for data science jobs. So maybe that's related to, if they're working on a physics PhD and spending time on on learning data science skills.
Absolutely, great questions. I think data science is very vaguely defined in the industry, and some places what they define as a data scientist and they expect from you as a data scientist is very different than other places. I would say I think this is probably true for the most part, that data scientist is being seen as a generalist. You're supposed to know a little bit about everything. You're supposed to know the math, you're supposed to know the programming, you're supposed to know how to talk to your marketing team, you're supposed to know how to talk to your president, the president of the company, and basically translate the ideas that you have, the scientific ideas that you have, to a business person. You're supposed to know that, how to do that. So there's a lot of things that you're supposed to know, but a lot of these you're not expected to dive in too deep, I would say, with a few exceptions. So for instance, the things that I've listed here, each one of these you can become an expert. You can become an expert of deep learning and just dive in, know a lot about deep learning. You can get, probably 2 PhDs in deep learning. There are a lot of things that you can do. However, you have to know also a little bit about software development, right? None of my data science colleagues or myself were software developers, but I figured if I learn a little bit of software development, I can simplify my days a lot. Instead of spending 8 hours working on an Excel sheet, I can spend maybe 20 hours writing a software that, so let's say that 8 hours was for many, many days in a row. I will spend 20 hours writing a software that will handle all of that for me by press of a button after that. So I didn't have to do that every day. So these are, but I didn't become a software developer. I just learned enough to satisfy the need that I had. Initially, that was the case on cloud computing when I first started. I realized the potential and how it can simplify a lot of the challenges that we had. One example was one of our clients at the time was Whole Food Market, and they gave me a subset of their data, and it was too big that it wouldn't fit any of the machines that we had in the lab. And I had to learn how to actually start a cluster and set up a cluster big enough that I can process their data so I can get back to them after the weekend. That was quite fun to figure all of that. Of course, I didn't become an expert overnight, but I learned enough to address what I needed. So to circle back, data scientists are generalists, so you have to know a little bit of each, but you also have to have your strength, and you have to market yourself that way. You don't want to say, oh, data visualization is not my job. Of course it is. You have to be able to communicate. If you cannot write a good report and communicate with the stakeholders, you're not going to succeed in that project. Even if you get the best accuracy, you're not going to succeed in that project. So you have to know a little bit of each. You have to be good enough at each, but then you have to become an expert in one of these areas. If you become an expert in, let's say, DevOps, then you're going to be a data engineer rather than a data scientist. So there's going to be trade-off, and different positions expect different things, and companies define these positions differently. I know that was a rather longer answer, but I hope I covered most of the parts. This is what I know.
Yes, thank you. And sorry that we just have so many questions coming in, so we're going to keep going for a few more minutes. So this one's a bit related. You talk about how you market yourself as a data scientist, but this question's about how can our experience in physics be pitched as a unique resource for application in data science? For example, can the mathematical or abstract side of physics PhD give someone an edge, or is it not generally useful?
I think, generally speaking, again, this is very personal experience. It would vary from person to person. When you walk in with a physics degree and you show that you have learned the skills to become a data scientist, no one is going to question your problem-solving ability and your math and stats. And in a lot of cases, no one's going to question your programming as well. So those are the areas that, of course, you still have to brand yourself. You have to brand yourself that way. But those are your strong areas that you would not be questioned. And you can be also intimidating to some by saying, yay, look, I have a PhD in astrophysics, or I had an undergraduate degree in physics, and people, I feel, they respect that. However, it comes with a little bit of a skepticism that that's good. You show that you're intelligent and you're hardworking, whatever. But is it only the theory that you know, or can you actually help me solve my problems? And that's a bigger question, right? So you have to be able to sell yourself. You have to say, not only I'm a great problem solver, but also I have solved these problems outside of physics. The example I gave for the forecasting rain, I spent literally 3 weeks because that's all time I had. It attracted far more attention than spending 5 years on my PhD. Far more, far greater, just because people could understand it. So you have to show that, hey, I have done other things outside of physics. And in fact, actually, let me tell you this very brief story about my job interview at Infor, the job that I got. I did multiple rounds of interview, and I had very good impression that this is going very well, until the last round that was on site, and I talked to a lot of people and gave a talk on physics, because they asked me, you can talk about your PhD research. So I talked about quantum mechanics, and there was literally no physicists in the room. I tried to simplify as much as possible, but I could tell it went horribly wrong. It went 3 weeks by, I didn't hear back from the company. Maybe 2 weeks, forgot. I emailed them, took another week for them to get back to me. They said, hey, we were wondering if you're available to grab lunch with us. I was like, sure. I was very confused because normally I was at a stage that you either get rejected or get an offer. The main question at lunch, the only question that was related, was that, what else have you done outside of physics? This was something that I had missed somehow. I never talked about anything, because the questions they were asking me, they were telling me what kind of problems they are tackling, and they would ask me how I would tackle it. So I didn't get a lot of chance to talk about my own experiences, and maybe it wasn't evident from my resume either. So that question came up, and I was like, now I see what it's about. So I told them about my app that I made for weather forecasting, and they loved it. They absolutely loved it. So I think, going back to the question, the strengths you have, I have highlighted here. I think these are the strengths that you have, and you can show visualization if you have published paper and things like that. However, there is a big skepticism for scientists that, can you actually do the job? Can you be practical? Can you finish it in 3 months? You have 3 months to work with this client. Can you finish it? And you have to have something to show them. And today, more than ever, there are opportunities for you to do, let's say, nothing is more relevant to COVID data set right now. There are several COVID-related competitions launched on Kaggle. So if you just go to Kaggle, you're going to see the main homepage, or just look up COVID. There are several data sets available. Download them, start working with them. First, find a problem that you're passionate about, and see if you can do some exploration first, some visualization, and then maybe some modeling, and see what other people have done. And then you can use it. And if people ask you and say, yes, I built a model, I did this, I did that, we can talk about it. So that is skepticism is far stronger than the strength that they see you. But if you can overcome that skepticism, then your other values that I have highlighted here, they will show themselves.
Thank you. Thank you for all of your detailed answers. We do have more questions, but unfortunately, this is all the time we have. I will quickly say that there were 2 requests for people to see your resume, and there's another request for them to hear your 30-second pitch or 1-minute long pitch. So if you're willing to share those, maybe add them to the slides that you're going to post online, and people can access them that way. Totally up to you. I will not request this. But yeah, so this is all the time we have today for the official webinar. Thank you so much, Mohammad, for taking the time to do this and giving such a great talk. We apologize if we did not get to your questions. We encourage you to follow up by sending an email to webinars@aps.org, and we will forward your questions to our speaker for comment. A recording of the video will be emailed to you within 5 business days, and this will also be posted on the summer webinar homepage. Lastly, in order to help APS continue to develop quality webinar presentations, please help us by taking a moment to complete the short survey as you exit the webinar today. This wraps up today's event. We hope you'll join us again next time. American Physical Society, copyright 2020, all rights reserved.
Thank you, Mithat. Thank you for having me. Thanks, everyone, for your time.
Bye.